Then let's go forward. The next property for the beta function, and this is again alternating definition for a beta function. The alternating definition is beta of mn, this is equal to 0 to infinity x to the power m minus 1 divided by 1 plus x to the power m plus n dx, right? So this is again alternating definition for a beta function. See, this may get confused with gamma function. Why? Because in the gamma function also limits are 0 to infinity. But please note that in case of gamma function, the terms under integral sign, they are x to the power n minus 1 and e to the power minus x, right? So e power term is not present here. So while comparing the integral with beta and gamma functions, please note the particular formats, okay? In case of gamma function, I need particularly 0 to infinity limit and x and e raised to x term. And here I am having x to the power m minus 1 term and 1 plus x to the power m plus 1. If these two formats are present, that means this definition I need to compare with the alternative definition of beta function. Okay. So to prove the property, let's again start with the definition of beta function. Beta of m comma n, this is 0 to 1, x to the power m minus 1 into 1 minus x to the power n minus 1 dx. Now if I compare the definition with the required equation, in that case, see, x to the power m minus 1 term is already present here, right? So the missing term is 1 over 1 plus x to the power m plus n. So while substituting here, just to change the limits, while substituting for x, I'm particularly go with 1 plus x term in the denominator. Okay, so let's take the substitution. X is equal to t upon 1 plus t. Okay, and why particularly I am choosing the particular substitution? Because see, using this equation t upon 1 plus t, I can find out value of x. The value of x is this x, just cross multiply. So this x plus xt, this is equal to t. Shift this xt terms to other side. So t minus xt, take t common, so 1 minus x. So value of t is here x upon 1 minus x, right? So reason behind choosing this particular substitution is the limits. That is, when I am substituting x is equal to 0 here, I am getting this is also 0. And when I am substituting x is equal to 1, so in that case denominator becomes 0. So t must be equal to infinity. So surely I am getting 0 to infinity limits in the required equation because of this substitution, right? So let's go back to this. Let's find out what is the definition for dx. I need to use u by v rule here. So this is 1 plus t whole square. So 1 plus t multiplied by derivative of t is 1 minus 1 plus t derivative is again 1 and this t as it is. T will get cancelled. So remaining is 1 plus t whole square dt, right? So let's make changes in the definition of beta function. So beta of mn, this is equal to 0 to 1, so 0 to infinity now, into x to the power m minus 1. What is x here? X is t upon 1 plus t raised to m minus 1 into 1 minus x to the power n minus 1. So that is 1 minus t upon 1 plus t raised to n minus 1. This is multiplied by dx. Dx is 1 by 1 plus t whole square into dt, right? Now let's simplify this little bit. So this is 0 to infinity t raised to m minus 1 and 1 upon 1 plus t raised to m minus 1 into this is nothing but 1 plus t minus t divided by 1 plus t. T will get cancelled, remaining is 1 plus t, and this is raised to n minus 1 into 1 plus t whole square. Okay, let's combine all terms together. In numerator only one term is there, t raised to m minus 1. In denominator, this is 1 plus t raised to m minus 1, 1 plus t raised to n minus 1. So add here n minus 1 and this square here. So clearly minus 1 minus 2 plus 2 get cancelled. The remaining is 0 to infinity t raised to m minus 1 and 1 plus t raised to m plus n dt. So beta of mn is with this new definition. Okay, so only variable changes there, but it's allowed in integration. So whenever I have limits 0 to infinity, terms are x and 1 plus x in the denominator. In that case, while finding out solution of that integral, I am going to use particularly this definition of beta. Okay, then next part is the fourth one, and yes, the fourth property is pretty much important.